Now, our last video on trigonometry, this video, the first part of bracing, and the next video, the second part of bracing, all go together as one big unit. So we're on our construction unit at the moment. And so bracing is when you've got a rectangular frame, like a wall frame, like behind me I've got a wall. In that wall there'll be a diagonal piece of timber bracing the wall to stop it from rocking from side to side. And so that's what we're talking about. So quite clearly, when you put bracing on a rectangular shape, you make a right angle triangle. So there's a frame that's going to build a wall in your house. If you put bracing across like that, it stops it from moving from side to side. If it moves one way, it's going to compress the bracing. If it moves the other way, it's going to stretch or put tension in the bracing. But that piece of timber, that piece of metal in the middle, holds it firm so the house doesn't rock from side to side. Now, with bracing, the strongest is when you've got a perfectly square frame, for example, 2400 mils by 2400 mils. That's a perfect square. That would give you a 45-degree piece of bracing. That's the strongest. Now, in building, you're allowed to use an angle that as low as 37 degrees or one as large as 53 degrees. So long as your bracing makes an angle in between those two, you're going to have acceptable strength. Now, here is example 5, comes from page 365 of your text. There's 3 parts to this question. Now, the first part is, what's the longest piece of bracing that we can put in here? So there's going to be a brace that's going to come down to there somewhere. So the longest piece of bracing that can go in there is going to make the smallest angle possible. So we're going to work out the length of that blue line, we'll call it X. So we have a right angle triangle set up. We've got our 37-degree angle. The 2800 is the opposite side of the angle. X is the hypotenuse. We know from some old hags can't always hide their old age. That with opposite and hypotenuse, there we are, that's opposite and hypotenuse, we must be using the sine of the angle. So the sine of 37 degrees is equal to the opposite, 2800 over the hypotenuse. Here's one of our ones with our unknown sides on the bottom of a fraction. You swap those positions. Plug that into your calculator. Make sure your calculator is set in degrees or else you'll get some strange answers. So the piece of bracing that you need there is going to be 4,563 millimeters in length. Part A. Now, part B is going to be, it's going to ask how far along this bottom plate is it going to reach? Let's just call that distance Y for the time being. So we know we've got 4563 mils here now. Now, you've got a choice. Since we know the opposite side, we know the hypotenuse side, we could use our cosine ratio if we wanted to, we could use our tan ratio if we wanted to, it doesn't matter. Whatever one you like the most. So I'm going to work out how far along the bottom plate. I'm going to use the cosine ratio. And the cosine ratio is the adjacent side, which is our unknown y that I want to work out, divided by hypotenuse, which I've already worked out at 4563. There's one of our unknowns on the top of a fraction. Bring the 4563 over as a multiplier. So if this is along the bottom plate, it's going to 3716 mil. Very good. Now, give me a moment. I'm just going to clear the board off and I'm going to go to the third question from this one. Now, our third question from this example is this frame large enough that we can actually use 2 braces? So if I can put a brace going from this top corner to the middle of the bottom plate, from that top corner to the middle of the bottom plate. Is it long enough? Remember, these angles have to fall between 37 and 53 degrees. If we can show that it does, it's good. Now, the best way to make it happen is this point here where the two bits of bracing come in is going to be halfway along the 5100. So we now know that distance there is 2550. Great. So I've got 2550 here, 2800 here. I can work out the size of that angle. I've got the opposite side, I've got the adjacent side, therefore I must be using the tan ratio. So I fill that in, tan my angle is opposite over adjacent. Now, the third type of problem, we've got an unknown angle. I undo the trig ratio, so I do the undoing of tan. So I've got 2800 over 2550. Make sure when you do it on your calculator, you have brackets in there as well. Plug that in, your angle is going to be approximately 47.7 degrees. And since it falls between the 37 to 53 acceptable rays, we say, so therefore, two braces are possible. Right. Now, there is the first video on bracing number 1. I'm going to work another example for you in the next video. So I'll see you then. Now, before I go, have you heard of this band that's going around at the moment? It's called 1023 megabytes. They haven't got a gig yet, apparently.